Hello friends, this video on Organic Chemistry Basics Part 45 is brought to you by examfear.com. No more fear from exam. Study a very interesting topic called chromatography. Please pay attention here, little tricky. So as the name suggests, chromatography, chroma means color and graphy means to draw. So it's more about the color, right? So it is used to separate mixtures by differential movement of components. I'll explain this, what this means. Differential movement of component through stationary phase under the influence of mobile phase. So we are talking about something called stationary phase, something called mobile phase, and movement of component. So we have three new terms to learn. Please note, differential movement of component is the first term, stationary phase is the second term, and mobile phase is the third term. Before we go into the understanding of chromatography, let me tell you why it is called chromatography. Because this is called chromatography because initially it was used to separate colored substance found in plants. Please note, now it is used also to separate non-colored compounds, but earlier in the initial days this was used to separate colored compounds. It's a very important technique, widely used in industry, very critical topic. Let's understand the concept of chromatography. So let's suppose this is my stationary phase, because this doesn't move, right? So I have some molecules here and they are in this phase. It's just like a floor, right? Stationary floor, correct? Now I have something called mobile phase. So these are my mobile phase, the one in the pink ones, right? They are moving their mobile phase. It is just like you're pouring water in the floor. The water flows, right? Similar to this is like a floor, it's called stationary phase, and the one which moves is called mobile phase. And now I'm talking about differential movement of components, right? So let's put two components here, right? Now what happens is I have to put two components here. The moment I have land this components in the floor, what will happen is this components will move, correct? But these components will move at a different speed. Why? Because there are so many factors. Maybe that the red components are more attracted toward the flow, the green ones are less, maybe, right? The force of attraction between, because there is some force of attraction between the floor and this components. So similar to the thing in water. So if you have this floor, in the floor you put a big stone, right? You put a big stone and then you put a very lightweight something, let's suppose safety pin, a very lightweight safety pin, right? Or any flower petals. Now what you do, you pour some water in the floor in one direction. You will see that stone will move very less. Safety pin will move all the more, right? So if, for example, I have a floor here, right? And I have a stone here, I have a flower petal here, and I have a safety pin here, correct? And if I put water here, I flush water in this direction. So what you will see after some time, when the water goes off, what you will see? You will see that your water goes off. You will see the safety stone is in the here, safety pin is here, and the flower petal is here, correct? You will see this, correct? Why? Because there is a force of more force of attraction between stone and this what you call floor, because the weight of the stone is more, and based on the weight actually in this case, right? So this will move more and this will move less. Similarly here, right? So I have two components here and I have this floor here and I have this mobile phase, right? Some liquid is flowing. The moment I drop these components in this phase now if you see what happens is they both flow, right? Because there's a flow of liquid here. Now if you see the cache here, the red ones flow fast and the green one flows less. Maybe the green ones are heavier, the red ones are lighter, maybe, right? So there can be reason. So, but in this case, if you see, now it has stopped actually, right? It has stopped because that's the max it can flow, and this is assumed that this flow has stopped now. So now if you see, this guy is less, this guy went more. Why? The same thing in the floor. In the floor you have stones and leaves and safety pin. So in that case the leaves went fast, this may be leaves, this may be stone, right? So with this, if you see, there was a compound which had both these compounds, right? I could easily separate them. Similarly, if you are given a stone and a leaf and a safety pin you want to separate, you can do the same thing. You can take a floor, you can put everything in the floor and put water, right? You can flush the water. You will see that all these are in different position. Same logic we'll apply in chromatography. Correct? So we'll see the things here. So if you see, there are various types of techniques in the chromatography. The first is adsorption. Please see this is what adsorption chromatography. Here I have column chromatography and thin layer chromatography, and then I have partition chromatography. So I'll understand all these chromatography techniques. First is adsorption, it's AD, and in adsorption I have column and thin layer, and then I have partition chromatography. Let's understand what is adsorption first. Please note there's a difference in adsorption and absorption. Let's understand what is adsorption. So if you see, you must have seen the leaves actually, right? And if you put water, the water sticks to the leaves, but it is not absorbed. So this is adhesion. If you see adhesion is AD, right? And absorb is, you have a sponge, you put water, it gets absorbed. That is absorption. But in this case, the water is not absorbed. It is adhered to this leaves, right? So adsorption is nothing but addition of atoms, ions, or molecules from a gas, liquid, or dissolved solid to a surface. There's a leaf, the surface called leaf. In this, my liquid got adsorbed, right? Not absorbed. Please note it is adsorbed because it's just addition. If you take the leaf and if you shake it, the water will fall off because there is a force of attraction that is holding this water. It got adsorbed. Correct. Similar example, you have water and you have, let's suppose, water spilled over floor, and you put take a paper. Don't take this napkin paper. Take the hard paper which you use, which you get from copy, right? In the copy, you take a paper. Just try to put water in that. So you see that the water is not absorbed by this paper. It is adsorbed. The water sticks to the paper. You shake the paper, the water will go off, right? Because it's a thick paper. Even if you take the ruler, the plastic rulers, right? The moment you touch or you put the plastic ruler on the spilled area, you see that some of the liquid get adsorbed in the scale. The moment you shake the scale, you see that all the liquid goes off. That is adsorption, right? Right? So if you see, this process creates the film on the surface of the adsorbent. So if you see here, there is a film here. So if you see the water also, the paper, here also if you see, there is a thin layer of water will be created. Here also thin layer of water gets created on the scale, right? And it is nothing but the game of surface energy, the surface tension, the surface energy which you talked about in physics. This is all because of surface energy. We talk about absorption. If you see, for example, you have water, you put the sponge, the whole water is sucked in the sponge, right? Or if you have water, you put some cotton cloth, the cotton cloth sucks the water, right? The whole water is sucked up. So that is absorption because the whole water is absorbed in the intermolecular space. So there is an intermolecular space here, right? And the water is absorbed in this. That is absorption. Adsorption is more about surface tension thing, right? It is just addition. If you shake it hard, it goes off. Correct? It's surface based actually. Please note, adsorption is a surface based process while absorption is the whole volume. If you put water here, right? The water is, and if you put a sponge here, you will see water molecule here also. But in case of absorption, if you have water, if you put a ruler here, you will not see water here. Water will only be in the bottom layer. On the top layer, there will not be any water for the scale. So hope you understand the difference between adsorption and absorption. So adsorption is more due to surface energy. It's surface based and it's nothing but addition. It's just addition, right? It is not the whole volume absorption, just addition. So let's start the chromatography based on adsorption technique. So in this case, the whole principle is based on the differential adsorption of various components of the mixture on a suitable absorption. We will explain this in the next slide. Let's start with the first adsorption chromatography, that is column chromatography. Let's understand the concept. So what I have done here is same thing. This is my floor, right? So floor is my adsorbent here. And I have a solvent which will be running. It's the water usually I have using the floor. And then I have some solvent. I have a mixture of compound. This is my mixture of compound. Correct? So what happens now is, if you see, I'll start the process. Now my solvent will run over this adsorbent, right? Now if you see, this guy is getting adsorbed. These two, right, green and red molecules are getting adsorbed over this adsorbent because this is adsorbent, right? This is trying to stick it. See, if you see, this solvent is flowing very fast, right? But these two guys are not flowing fast. Why? Because there is a force. There is a resistance from this adsorbent. This adsorbent is trying to stick these guys, these two guys. It is trying to stick green ones more. Greens are more stuck, you can say. So what happens is, if you, I'll show you the process once again. This adsorption is adsorbent is not absorbing the solvent, right? But if you see the compound, the green ones and the red ones are getting adsorbed. The green one is getting adsorbed more. There's a more retaliation. There is more resistance to the movement. So green one is moving slow. The red ones is moving little fast, right? But the faster is still the solvent, correct? So you see once again, the solvents are moving fast because the adsorbent which I am using is not absorbing the solvent, but out of this green and the red ones, it is the adsorbent is absorbing this compound, right? The green ones are getting adsorbed more, so it's moving slowly. The red ones are getting adsorbed less, so it's moving a little fast. So if you see now, after some time, these two are getting separated, and now we can separate this because it is separated. Now we can separate this easily, right? You put more and more solvent, it will come down. This is a technique actually. If you see, this is a technique. You put more and more solvent here, come down. I'll explain this process in the next slide. So there are various steps to this column chromatography. The first one is the preparation of column. So this is my first. So I take a test tube. I put a cotton, the glass full at the bottom of the column, and I put an adsorbent here. So this is my adsorbent actually. This is my adsorbent. Correct? So this is my floor actually, on which I'll be putting water or solvent. This is my adsorbent, which will adsorb the organic compound. And normally this adsorbent is what? My stationary phase, as I've shown you. This is stationary phase because this doesn't move, right? And it has to be uniformly packed. If it is not uniformly packed, you won't get good results. We'll not discuss in deep about chromatography because we need to just understand chromatography in basic. But actually, if you have, let's suppose, some hollow space or something in the adsorbent is not properly packed, it won't give good results, right? We can explain that, but that will take time. Okay, leave that part. Just understand that it has to be uniformly packed, and that's very critical actually. If it is not uniformly packed, it will not give good result, right? And some of the adsorbent we use is alumina, magnesium oxide, silica gel, starch, etc. Now, what is the second step? Second step is adsorption process. So here what we do, the solution to be purified. So here this is my organic compound to be purified, right? This is my organic compound to be purified. The brown one. So that is put down. Correct? Now, but this will not move, right? So this is like I have a floor, I have a stones, leaves, and those kind of stuffs here, right? Pins here. Now I have to make them move, right? To make them move, I need what? Solvent. So I need solvent. So this process is called elution actually. I put some solvent here on the top of this. Now with this solvent, what happens is, as I told, solvent goes down, right? And this solvent kicks this organic compound. And since this whole thing is my adsorbent, right? It will adsorb these organic compounds at different rate. And that's why if you see, these organic compounds are broken now, right? This get adsorbs more, so it is going at a slow speed. This adsorb faster, you get this kind of structure. Now it is here, you want to collect it. You keep putting more and more solvent, right? You keep putting more and more solvent, it will come here. The moment it come here, you change the beaker and collect this. And then you stop for some time. Again, you collect the solvent, and again you change the beaker and collect this. And with that, if you see, you have separated this organic compound into two different compounds. Hope you understand this method. So the first is preparation of column. You put the adsorbent. It has to be uniformly packed, else it won't work properly. And then you put this organic compound to be purified, right? And then this is as good as putting stones and leaves and what example I took was, pins, right? I want to separate this. Now I have to flush out this. To flush, I will use solvent flush out this, and with this, if you see, both are separated, and I can collect them. And you keep putting more and more solvent. Let's understand thin layer chromatography. So as the name suggests, thin layer chromatography means we have a thin layer of adsorbent. We have a thin layer of adsorbent. Correct? This is what thin layer and chromatography is. Here you separate the mixture over thin layer of adsorbent. So the first step is to prepare TLC plate, something like this if you see. So what we do is you take two plates actually. So if you see there are two plates, right? There are two plates. So there is one plate and one more plate, glass plate, and in this space between you put a thin layer of adsorbent, namely mostly silica gel. You put this adsorbent over this, so you have this silica gel in this, right? And you have this two glass here, it's a very thin layer, and you draw starting line. For example, in this case, right? So in this glass you would have, there was a glass here. For example, in this case you draw a starting line here, not straight, yeah, right? You draw a starting line here, and you put the silica gel, and then the mixture which is to be separated you put somewhere here, very small fraction, one dot, right? And then you close the glass. Actually you get something like this, right? So you have two glass at both the end, you have silica gel here, and you have some mixture somewhere here, the mixture to be separated, correct? And there's a line which already we have drawn in this fashion. So we have something like that. So in this we have a mixture to be separated, and we have all silica gel, that is adsorbent here, correct? Now what we do is we put this in a closed jar containing a solvent. Sorry, this was adsorbent here. So in this we had put adsorbent, correct? And this is the solvent. The blue one is my solvent, correct? The one in this glass or the one here is my adsorbent, correct? And these are my organic compound or organic mixture actually to be separated, correct? This is my organic mixture, this is my adsorbent, full of adsorbent, this is my glass, and I am putting this in the solvent. Now due to capillary reaction, after some time you see this will rise. It will rise. Now this is nothing but flow of solvent in this direction. If you see the capillary reaction, the solvent is flowing in this direction, right? So now this capillary, the solvent is flowing in this direction. These are my organic mixture. This organic mixture is also expected to flow, but since there was a resistance from this adsorbent, because this is full of adsorbent, this is adsorbent actually, right? This is adsorbent. There is a resistance from this adsorbent, and then they flow with a different speed. So if you see, now this mixture got separated, the one in the red and the one in the blue, correct? So typically this method is not used to separate organic compounds. Why? Because see, in this case we just use a dot, right? A very small tiny amount of organic mixture. This is basically used to determine the rate of flow of the organic, or the speed of the organic compounds, right? For example, as I told in the last technique, where I showed that one organic compound moves faster, one moves slower. Now if you are curious to know what is the relative speed, right, of organic compound A and B, let's suppose the mixture had organic compound A and B, so what is the relative speed? So for that we use this. So now we have a starting line and we have this ending line where we have seen the solvent has reached, right? And now we have, from this point, this is the distance my mixture has reached, and this is the distance by my solvent has covered, right? So we have something called retention factor. That is nothing but distance moved by the blue component. I mean, if I'm talking about the retention factor of blue, divided by distance moved by solvent. If you want to find the retention factor of the red one, if you see, the retention factor of the red one will be the distance moved by the red organic compound by distance moved by the solvent. So if you see the retention factor of our red one is more, that means it moves faster, correct? The retention factor of blue is less, that means it moves slower. So with that we have some quantitative number to tell which organic compound moves faster and which one moves slower and at what rate, right? So for that we use this thin layer chromatography techniques, correct? So what we have done here, we took this two glass sheets, we have put this silica gel or adsorbent here, we have put the organic compound to separate, we have put a line here, we have put solvent here, right, in this jar. Because of capillary reaction, the solvent will move up. The solvent will force this organic compound to separate, right, and it will move at a different speed. It will reach here, it will reach here. So with that, you can find what is the retention factor of the blue, what is the retention factor of the red organic compound. Correct. Let's talk about the partition chromatography. So in this chromatography, we have, it is called liquid chromatography actually. Both the stationary and the mobile phase are liquid. So in the early examples you saw, right, my stationary phase was solid. Correct? It was almost solid. It was, but in this case, both of them will be liquid. A good example is a paper chromatography, where you use a special paper called chromatography paper for the chromatography. Here if you see, water is the stationary phase, because water is the one which is between the holes of this paper, and the liquid mixture which I am using is the mobile phase. Same thing, similar to TLC techniques actually, but instead of using the TLC plate, I am using here paper, chromatography paper here. So here also you put this organic compound, and if you see after some time, because of capillary reaction, the solvent will go up, right? Solvent goes up, and if you see, this solvent force this organic compound to break into these all organic compounds, and then you can find the RF value for the red ones, the blue ones, the pink ones, the orange ones, sorry, the green ones, the yellow ones. Correct. So this is an example of partition chromatography. Here, both the stationary and the mobile phase are liquid. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.